till Monday. This is really important. This is how we define a logarithm. This is what we call, on this side, the logarithmic form. And this, on this side, is what we call the exponential form. Okay, and so we're going to rewrite some of these examples and then we're going to evaluate them, okay? So this is a 5, right? So that becomes the base over here. We're going to rewrite this with an x and a y. This is what y is. So where does it go in the exponential form? On the other side of the equal, okay? And this is what we're trying to figure out. What is y? Five to what power gives me 125? The third power, right? So y equals 3. So now, hopefully as we go, you're gonna, well, I'm gonna just keep asking you, what power of 5? But this is really what it means in exponential form. Okay? What? Okay, so if the base, I'm rewriting these in exponential form. The base becomes the base here. This number is 125. Where does it show up? Where does y show up in exponential form? On the other side of the equal sign. So I put 125 there. And what we're trying to do is we're trying to figure out, well, we're trying to figure out x, I guess. Would you like it to be an x? Yeah, here.
Where is 5?
5 is the base. So what's the base in letter B? 7. Do we know x? Nope. What does it equal? So 7 to what power? 7 to what power equals 1? Okay. What's the base here? 1/3. 1/3 to some power equals 81. Well, 1/3 I don't know because it's a fraction, but I know 3, right? 3 to what power gives me 81? Well, you're right. First of all, Lucas is right. In order to get it to be a 3, I need to make it negative. Okay. Let's see. 3 squared is 9. 3 cubed is 27. 3 to the 4th power. That's -4. Okay, so let's try this one. What's the base? To some power equals the square root of 2. Gosh, you got to really think on this one. Well, first of all, what power of 8 gives me a 2? 8 to what power gives me a 2? The 1/3, good, because it's the cubed root. Okay. But then I need it to be a square root of that. So that's to the 1/2, right? So if I do 1/3 times 1/2, this is 8 to the 1/6. I should go back and do this. Hold on. Okay, here's why. This is what this really means. What's 8 to the 1/3 power? 2. What's 2 to the 1/2 power? Alright, we're going to do some more. But first, let's talk about some common bases that actually your calculator will evaluate. This is called a base 10. It's called a common logarithm. And your calculator writes it with no base. So it is written y equals log of x. Does anybody know what base e is called? But what kind of logarithm has? Good. This is called a natural log. I spelled natural wrong. Do you remember what it looks like? Instead, it doesn't say log base e, but sometimes you might see it like that in your calculator. So when you see it written like this, you have to know that's base e. Okay? Okay. So if it helps us, let's rewrite these in exponential form. Here's what I'm trying to figure out. Remember, a log is finding out the exponent of the base. What's the base of this log? What's the base of this log? Look up here. If I don't write a base down, what kind is it? Common log. So it's 10. What I'm trying to figure out is this. I'll try to do a better job than before because you're not liking the equation thing. 10 to what power equals the 4th root of 10? I can. 10 to, this is what I'm trying to figure out. 10 to what power is the 4th root of 10? Just 1/4. All right, let's try to figure out this one. What's the base of natural log? E. So, and what I'm trying to figure out, I'm going to circle it right here. This is what I'm trying to evaluate. I'm trying to figure out the power of E, or the exponent of E. E to what power would give you 1 over E? Very nice. E to the -1 power would give you 1 over E. Okay. Let's go to a consequence of the inverse, and then I'm going to give us some more to practice. Okay? A consequence of the inverse property of a log is that when you take, because they're inverses, when you put an inverse in its function, they undo one another, so you should get x back. So if I do b to the log base b of m, the b and the log base b undo each other, and it should output m. Same thing going the other way. If I do log base b of b to the m, they essentially undo one another, and I'm left with m. So you should know that inverse property. So let's check here. Log base 6 of 6 to the 3rd. This is what it's asking. 6 to what power is 6 to the 3rd? This is what this means. 6 to what power is 6 to the 3rd? It's right there. 3. This is base what? 10. 10 to what power is 10 to the 5th? 5. Okay, so that's really what it's doing, but do you see how the log base 6 and the 6 undo one another? So as long as they match, log base 6 of 6 to the 3rd, what would be log base 6 of 6 to the 7th? 7. Okay, let's go the other way. If you have e to the natural log, those are also inverses. They undo one another. What should that give you? 5. How about 8 log base 8 of 7? What should that give you? 7. Okay, let's do some more practice. Let's rewrite a couple more. And I'll mix up the bases, okay? So let's write them in exponential form. I want you to evaluate log base 2 of 8, and then we're going to write it in exponential form, okay? What's the base? 2. I'm trying to figure out what power of 2 gives me an 8. If you want to check, what you do then is write it, this is its log form, write it in exponential form. In exponential form, this is the base. The other side of the equal sign is the power equals 8. But this was the solution we were looking for. This is why. Okay?
Did that, so we have to write it.
You should be able to do both.
Okay.
Okay, how about that one? It's 2. Why is it 2, Nathan?
Because 3 squared is 9.
Yep, I'm looking for the power of 3. 3 squared is 9, so the answer is 2. So the reason why is because 3 squared equals 9. Okay? Alright, let's ramp it up a little bit. Log base 5 of 1 over 25. Negative 2.
Yeah,
Oh, let's do one with a half though, so you can see what that looks like. The reason why it's negative 2 is because negative means to take the reciprocal. 5 to the negative 2nd power would be 1 over 5 squared, right? Which is 25. Okay, but that brings up a good point because we should do some fraction powers. Okay, we'll do some common log. That's common log. So what's the base? 10. So what's the log of the square root of 10 equal to? 1/2. Because 10 to the 1/2 power is the same thing as the square root of 10. How about the log of the cubed root of 100? So we have two things going on. We have this is not 10 anymore, but what power of 10 is it? 2. And then it's a cubed root. What power gives us a cubed root? 1/3. This is the 2/3 power because 10 to the 2/3 power means the cubed root of 10 squared. Which isn't that the cubed root of 100? Okay, ready for a doozy? A doozy? Hard one. Natural log of 1 over, if you can do this, you're already like a master. Nope, no calculator. I see you reaching. Nope.
Moving it.
No. I'm just giving you a hard time, Nathan. Alright. Let's do the 5th root of e squared. There's 3 things going on here. Think hard, even though it's only 8:18 in the morning. See if you can get that one. See if you can at least get part of it. You should be able to at least get part of it. Okay, he said negative 2 over 5. Let's go piece by piece. 1 over is negative, correct? So let's cover that up because we talked about that. This is e squared, so it's a power of 2. But then 5th root, that's the 1/5 power. This is negative 2 over 5. I'll go through it. If I had said to you, find e to the negative 2/5, this is what you would do. First you would do 1 over e to the 2/5. Agreed? And then you would make this the 5th root, and this the power of 2, so you would say that's 1 over the 5th root. That's that over 5 e squared. So that is y. That is y. Okay.